All right, so we're going to finish 9.4's notes today, and then we're going to work on the review of this whole chapter for the quiz. Remember, the majority of the quiz is multiple choice, but that doesn't mean it's just guess, right? Okay. I'm going to start with talking about this again. Anybody remember some of the rules or some of the similarities we found as we were doing this thing? From the TAN reference sheet, what did we notice? Okay, every equation had to have a 1 down here. If it didn't, then we couldn't find E or D, right? We had to make the equation have a 1 plus or minus on the bottom. Okay, so the 1 was important. What else? Perfect. If it's cosine, then it is, the directrix is vertical, so it's an x equals line. X and cosine, that should kind of be glued together in your head, right? And sine was horizontal line, y equals. Sine and y are kind of glued together in your head. All right. Then there was this whole both E and D had to be positive business. If they are both positive, how did we know whether this was a plus or minus back here? If it's a plus here, it's a plus back here. If it's a minus E, it's a minus D or opposite of D, okay? Same, doesn't matter if it's a sign, it's still plus E, it's positive D, minus E, negative D. Seem okay? All of this is on the TAN sheet, and you get to use it. It's not anything you need to memorize. All right. We did 4 and 5 yesterday. Before we talk about 6, before we talk about 6, I want to do one like this just because there aren't very many. Okay. I'm so tricky, guys. What did I do? Okay. I moved the 1 to the back. Jared said parabola already. Where is he getting that? The eccentricity is 1 because what's in front of sine is E, right? Let me write that. ED equals 1 plus E sine theta, right? That's what the sheet says. So E is what's in front of the sine, so 1 is E. Eccentricity of 1 is a? Yeah, circle eccentricity is 0, okay? Parabola is 1. Genius, Jared. I don't know if you meant that when you said it, but it was right, okay? What else do we know then? Yeah, if ED up here is 4, and somebody figured out E was 1, then D is 4. So the equation would be, it's got a sine. Sine is y equals, do we need a minus? Nope. So the directrix is y equals 4. So y equals 4 is this line up here somewhere. So I'm thinking this parabola looks something like this, okay? We could graph it. Remember we did these, and we'll do some more in a minute, but okay. So fiddle around with number 6 for a second. Anybody have it with a 1 yet? What'd you get? Okay, wait a minute. What, when you just changed so that there was a 1 here, you had to divide. Riley wasn't here when we started this at all. It has to have that 1 down here at the bottom. Okay, so we decided to divide everything by 3. Now, take note, whatever you do at the top, you got to do the bottom, right? So that it's really a form of 1. So 9 divided by 3 is 3 on the top. Down here, 3 divided by 3 is 1. 6 divided by 3 is minus 2 cosine theta. Does that seem okay, Riley? All right. Now, this is equal to ED and 1 minus e cosine. I don't have room to write that. But what does e have to be then? 2. And it is positive 2. E is always positive. Okay, now if e is 2, that's greater than 1, which makes it... Okay. All right, now if the top is 3, that means that e times d is 3. But we just figured out what? E was 2, so that makes d 3/2. So the directrix is it x equals or y equals? It's cosine, and it's on the sheet. Okay, just let me show Riley. If you had this equation with a cosine and a minus, is that what this one was, guys? So we're looking at this, then it says the directrix is x equals opposite of d. Okay, it's right there. You get to use the sheet. So this one is going to be x equals the opposite of d was 3/2. Okay. What mode, if I want to check the graph of this, would my calculator need to be in? Radians, because we do all these in radians, and polar. Okay? This quiz, I think you can stay in polar the whole time. That won't matter. But you do have to switch a whole bunch of times between degrees and radians. Don't hurt me, okay? But when you're graphing, it's in radians. So if I put this in radian mode, and I go here and I'm going to type the original one in, just to make sure that I didn't do anything silly. 9 divided by quantity 3 minus 6 cosine theta, close. Okay, my window is like 0 to 2 pi by 0.1 and -5 to 5, -5 to 5, except then I did a zoom square. Okay, remember it draws the asymptotes in because it connects all the points, but does that look like a hyperbola? 2 hyperbolas? A pair of hyperbolas? The whole thing together is a hyperbola? Whatever. Okay, x equals -3/2 would be somewhere over here. Like at -1.5. Does it seem like that would be the line that these are opening away from? I think we're good. All right. Now we get to go backwards. Okay. They're going to give us the E and tell us the shape and all kinds of good stuff, and we're going to figure out the equation. It's not hard. I promise. I promise. Okay. What is this equation? What is this information telling us? If E equals 1, it's a parabola. All right. If the directrix is x equals 1.5, can you go to your sheet and find x equals a positive number and tell me what the equation? Can anybody do it without telling me? Looking at the sheets? It's going to have a cosine, 1 plus e cosine, and it's always ed, right? Okay. We can fill a bunch of junk in. What do we know? E is 1, so that's a 1 here and a 1 here. The bottom's done. And E times, oh, yeah, this is just D, right? The equation is x equals D. Yeah, we don't have to do any work. Just kidding. The equation is x equals D, so therefore D is 1.5. So we get 1 times 1.5 is 1.5 over 1 plus 1 cosine of theta. Now, you could type that in your calculator and get the picture, but as far as writing the equation, I promise this isn't going to be one of the choices. Because it's kind of a math teacher thing. We don't like decimals within fractions, and we don't like fractions within fractions if we can get rid of them. What if this is a really like a 3/2, right? What could I multiply top and bottom by that would get rid of the fraction? What's the only denominator of any part of this? A 2? So if I multiply the top by a 2, I also got to multiply the whole bottom by a 2. So it would become what? 3 over 2 plus 2 cosine theta. Now that doesn't seem all that different or all that fun and exciting, but that's the form it would be in for the multiple choice question. Okay, guys, they'll always have integers in there. If we go to the calculator so that we can graph this one, we had, what did we have? 3 divided by 2 plus 2 cosine. Is that what it was? Before I wrote over the top of it? Or put the calculator over the top of it? Okay, I got a parabola opening left. The directrix at x equals 1.5 would be over here, yes? It won't let me draw on this today. Oh, maybe if I turn that on. Clear ink. Now it'll let me draw over here. Nope, just kidding. The pen writes in ink. Okay, here's my pen. There we go. Does that seem good? X equals 1.5? Beautiful, yes? That's where the directrix should be for a parabola opening that direction. Okay, here we go. Try number 8. What can you tell me? It's a sine. Good. What else can you tell me? It's a hyperbola. How do you know it's a hyperbola? Okay. Oh, E is greater than 1. Okay. What's D? Be careful. It's 3. D equals 3. What is the fact that this has a minus? Tell me. Yeah, it's going to be 1 minus sine. We're done, aren't we? 1 minus, be careful, it's not 1 minus sine. It's 1 minus what? It's 1 minus E sine theta all over ED. So we'd have 1 minus 3 sine theta. What's E times D? Yep, D is positive 3, right? D and E are both always positive. Okay, it says it right at the chart, top of the chart there. So I don't think we have to do any crazy schmazy stuff with this one, do we? All we have to do is type it in. We got 9 divided by 1 minus 3 sine theta. Okay, again, it's drawing the asymptotes. I can turn off the connected mode and draw it in dots, and then you just won't be able to see it because it'll be a bunch of little dots. But if my ink thing is working, I can try to go over them for you. Some of you in the front row see those dots right there? And my writing over them in green on green does nothing. Okay. Woo! Ah! I could just give up. Where's my cursor? Oh, yeah? If you're in connected and you go back here and you do like this thing. Oh, I don't want connected. Am I in dot? For bigger dots? That's awesome. Okay, so this is connected. I don't want it connected. If I keep hitting this, is that bigger dots? Yeah, that's connecting them. Did yours work? You might have the new, oh, you have the same, should have the same thing I do. I don't know. It isn't offering me a choice of bigger dots. You might have a newer operating system or something than this one has. Anyway, all right. Now I forgot where it was. Was it opening up and down? Over here? Oh, it was down here again? Okay. Y equals -3 would be down here. So I'm thinking it must have been doing something like this. Is that close? Not even. Okay. Let's move on. I feel like we spent a half hour on that problem. Okay. E is 1/3, which makes it a what? Less than 1 makes it a what? Ellipse. Okay. And D is 3/2. And this is a x equals, so it's got cosine and it's positive. Okay, so if we start filling in r equals ed over 1 plus e cosine theta, what will we have? E times d is 1/3 times 3/2, which sounds like it's going to be 3/6 or 1/2. Good job. Over 1 plus 1/3 cosine theta. Okay, we need to get rid of both the 1/3 and the 1/2. What is the common denominator that will get rid of both? 6. So we're going to, now, because this is what somebody's going to do. They're going to say, oh, I'll multiply the top by 2 and the bottom by 3. Does that law of algebra that it's okay to multiply the top by 2 and the bottom by 3 and you won't change the value? Not so much, right? Whatever we do to the top of the fraction, we got to do to the bottom of the fraction if we don't want to change the value. So we get 3/6 plus 2 cosine theta. Some of you already got that far. Did I lose anybody? Okay. I remember trying to graph this one earlier and it was nearly invisible. What did I do wrong? This particular calculator emulator is called a Webbit. I don't know. Maybe that's the guy's last name who developed it. I don't know, but you literally Google Webbit. EMU is, yes, EMU stands for emulator. Or it's a particular kind of bird. It's a Webbit emu. All right. Did you get a teeny tiny little, okay, ellipse? What was the, where was the directrix again? X equals 3/2 is 1.5 over here somewhere, okay? Yeah, it just feels wrong, doesn't it? And you don't have to. You don't have to draw it. It's just that I do it to check that it was reasonable, that everything went together, okay? That it made sense. Okay, last little part of the worksheet, and then we'll work on worksheet 11. Can you try these 3, guys? All 3 of these are luckily the same equations. You don't have to do 3 different ideas. Okay, first of all, what did they do to try to trick us? Okay. First of all, I'll tell you what's going to happen. The choices are going to be E equals 8, E equals 16, E equals 6, equals 48, equal, I don't know. Yes. It's 48 over 16 plus 8 cosine theta, but what needs to be a 1? The 16 does. We got to do a 16 here, a 16 here, and a 16 here. So we get 3 over 1 plus 1/2 cosine theta, which I know we just spent a lot of time getting rid of the fraction down there, but this is the one that will tell us E, right? This form. So this is equal to R equals ED over 1 plus E cosine theta. So the first question just asks, what's E? 1/2. Everybody good? The second question says, what is the directrix? Okay. It's a cosine, so it's X. So we get rid of that choice and that choice. And then we need to figure out what D is. E to times D equals 3. E was 1/2, yes? So half of D equals 3. If we multiply by 2, we get D equals 6. So I think it's not A either. X equals 6 is the directrix. And the type of conic, they saved the easiest question for last. If the eccentricity is 1/2, We good? Yes? Are there two kinds of ellipses? Like a solar, like a eclipse. Ah, that only has one L. I was like, wait a minute. Does it have Okay. It's a moment. I'm good. All right. We okay? So that was the rest of that lesson. Now we're going to switch over and work on worksheet 11, just because I love you all and want you to be able to get your homework done faster, okay? But also because if we don't review this, I don't think you're going to remember how to do it. So at the top of worksheet 11, it says to do some book work. The book work that's first listed is at 526, guys. On the side A. No? Am I totally making up problems? Okay. Page 526. All right. What I did was I very nicely made a slide where we just do 21 and 22. Okay. So these are the two. Hopefully nice and big. You can all see them. These are off page 526. The directions say find the component form and magnitude of a vector AB with the given initial points and terminal points. Hint. These are not little triangular parentheses. These are ordered pairs, not components. So you're not adding these together. Number 21 is talking about being over here 8 and down 4 and over here 6 and up 1, and it's going from A to B. So what are the components that would get you from A to B? Who remembers how you do this? Okay, kind of, yes. How far over and how far up? What? You subtract the x's and you subtract the y's. Now, this is not how I would have done it. That's the rule, though. This will do it. My rule, remember, was you're going from A to B, so you went 14 to the right. And then you're going from -4 to 1, so you went up 5. So we're figuring out how far over and how far up. And then we have components. Now we have to find magnitude, which is our favorite Pythagorean theorem. 196 plus 25 is 221, which is like 14 point something, almost 15-ish. Okay. So components and magnitude, we good? Okay, so do 22. Well, you remember how. Or save it and do it the day before the quiz. Or redo it the day before the quiz. Or you could do 19 and 20 the day before the quiz. I'm just full of suggestions today. I got 1-5. Did anybody else get 1-5? And that would be square root of what? 26 for the magnitude? We good? Can we move on? Now that you remember how to do those? Okay, the quiz is not till Tuesday. Today's Friday. So you may want to review that again, right? Just suggestion. Okay. These I think you would have remembered. Do we need to do these together or you want me to skip them? Do 23 maybe or do 24? I don't care. 2 times Q. So that's 2 times, and this is where I always use the wrong points. Make sure you write down Q is this guy. And then it says subtract P, which is this one. So if we double these, you don't have to show all this work. Then we're supposed to subtract this one. What do we get? Careful, we're subtracting. -4 minus 4 is That would be what I would have done, Riley. I would have put 0. Everybody okay? All right. Can I skip 24? Okay. Unit vector. All right. You remember me saying nobody ever gets these right and they're not really that complicated, and now you don't remember how to do them. Okay. This says if I were to go left 7 and up 2, that would be vector V. Okay, there's vector V. He went left 7 and up 2. We are to find a unit vector that goes exactly the same direction as V. Okay. A unit vector is kind of like when we were doing unit circle, the radius had to be 1. So this needs to be exactly 1 unit long. So I'm going to shrivel this thing up so it's going exactly the same direction, but it's only 1 unit long. Nobody remembers how to do that little shrivelly business? I'm going to talk about 28 for a second, see if we can figure this out. Number 28 says go 3 over and 3 down. How long is this side right now? How long is the vector if it went over 3 and down 3? How long is the vector V right there? Square root of 18, which is 3 square roots of 2. How would you shrivel that down so it was exactly 1? Divide both of those by 3 square roots of 2. Go back over here for a minute. How long is this one? 2 squared plus negative 7 squared, square root of 53. So this length is square root of 53. If we want it to be 1, we got to divide everything here by square root of 53. They're coming back to you now. You divide each one by the magnitude. It was some really disgusting, like, it looked like that on the notes or something really disgusting. It's just 1. You just divide by the magnitude. Remember me saying, why would you write it like that? Okay, so we're going to have negative 7 over square root of 53, comma 2 over square root of 53, which Hofbauer is going to mark wrong, right? Because she's really mean and she's going to make you write what? Square root of 53 over 53. And I'm not going to make you write anything because it's probably multiple choice. But 2 squared is 53 over 53 would be the other correct choice. Okay, so can you finish 28? Because I think you're going to finally make a connection when you finish this one. If you divide these by 3 square roots of 2, what happens? These will be 1 over the square root of 3, which is, that's a 2. Just kidding, it's a 2. It was never a 3. I just lied. You get 1 over the square root of 2, which is square root of 2 over 2. And this one you divide and you get a negative 1 over square root of 2, which is negative square root of 2 over 2. Oh, this is the ordered pair here on your unit circle, and the radius of the unit circle is what? 1? Now is it making a little more sense? Not so much? Okay. Just remember, you divide each one by the magnitude and you'll get there. All right. I was just trying to make it make a little bit of sense, but this looks like it's not a parametric equation. I thought we had to do parametrics. I was all excited, but it's not. It just says find the magnitude of the horizontal and vertical components. Okay. Yeah, we just do sine and cosine. So which one is horizontal? 55 cosine of 25. What mode should our calculator be in? Degrees. I could talk. Okay, so making sure we're in degrees this time. We type 55 cosine 25, and we get 49.8 maybe? Okay, that is a magnitude in and of itself. That is the magnitude that it goes to the right horizontally. So I just want you to know that because, well, we always wrote them like this, right? And then we did 55 sine of 25 and got the vertical one to be 23.2. Did anybody else get that one? Whoops, that's supposed to say vertical. On the quiz, it specifically asks what is the vertical on one version, and the other version says what is the horizontal. So you only would give me one of those numbers, not the whole ordered pair thing. Does that make sense? Okay. Number 54. Miriam's pushing a stroller with a force of 200 newtons at an angle of 20 degrees below the horizontal. Okay. Below the horizontal is like this, 20 degrees. Does it make sense that this might be how she would be pushing at a stroller? Baby. Okay. That makes sense that she's pushing like that, kind of? Okay. She's pushing with a force of 200 newtons. What are we going to do? 200 cosine of negative 20, 200 sine of negative 20, because we should get a positive and a negative, right? Everybody good? There is a bearing question about an airplane and the wind. It is a bonus question. Okay. There's this kind of a vector question, but these are both going in a first quadrant direction. When you add them together, you still get a first quadrant answer. So can anybody just talk me through the process? Yeah, do 3.4 cosine 75, 3.4 sine of 75, 2.8 cosine of 50, 2.8 sine of 50, then what? Add them together. Once you've added them together, the magnitude would be from doing the Pythagorean theorem, right? And the direction would just be inverse tangent of the y over the x components. And because it's a first quadrant angle, first of all, what mode do they want? Degrees. Because these are both first quadrant, there's no like adding 180, subtracting 180, dividing by 360, any goofness, okay? Which you never divide by 360. I was just throwing that out there. All right. I'm going to do this one instead because this one is a little hairy. A force of 27 Newton pulls at an angle, I don't like these words, 23 degrees above due west or east. Really? Has anybody ever said 23 degrees above due west? East? Yeah, I can't even read. Okay. I kind of like this question because I like my analogy that I'm going to use in a second here. It says a force of 33 newtons pulls at an angle of 55 degrees below due west. Okay, that's over halfway. It's kind of doing this way. 55 degrees below due west, which is really weird. But this is how I envision that. Oh, that was supposed to be what? 33 newtons? Not 27? Okay, this is my analogy of what's going on here. Do you remember the scooters you got to play on in elementary school? They were really fun until someone ran your fingers over or you ran your own fingers over. Okay, I'm going to talk about these only because the idea is I'm sitting here on my little scooter and someone is tugging me this way and someone else is tugging me this way. Where am I going to wind up flying? Down here somewhere, yes? That makes sense? Because when we start doing these components and add them up, it ends up in the fourth quadrant and everybody's like, why? I don't get it. But does it make sense if you're pulling that way? That's where two people are pulling that way? Okay. Now, they're also pulling very much against each other, right? So we'll see what the force turns out. Okay. Help me out. How do we find the components of this one? 27 cosine 23 in degrees again. And what about this one? Be careful. 180 plus 55, so that we get the right signs, would be 235. Is that right? Did I add right? So I have 33 cosine 235 and 33 sine 235. Okay, adding those up, what lovely decimal components do I get? I got 5.9 for the first one. Anybody? May I get the second one already? 5.93 maybe? Anybody else do what I do? I just like go back and change it to sine, because I'm too lazy to retype it. Negative 16.48. Is that not what you got, Emerald, or is that what you said? Okay. All right. Now what? How do we find the magnitude? Square root. Anybody? How many newtons of force? 17.5 newtons. Okay, why is it so much less? This one was 27, this one was 33. Yeah, because they're like pulling against each other almost, right? I still get to go flying forward, but not that much. Okay. Degrees. Find that stupid direction part that we hate. Second tangent of negative 16.48 over 5.93. Negative 70 something degrees. Okay. And is that in the right quadrant, negative 70? Yeah. Can we go back and try to figure out how they would explain that in this problem? If this is a 70 degree here, negative 70, what might they have said? They said above due east and below due west. 70 degrees below due east. Now, it's not like that on the quiz, okay? But I'm just saying that's the wording they're using. But we're good. We figured out what quadrant is in. I'm happy. All right. This one says a constant force of 15 newtons being applied at a constant angle of 30 degrees on an object. At the same time, a constant force of 25 is being applied at an angle of 60. What is the magnitude and direction? Both first quadrant, just like the first one. I think you can do it. Yes? Okay. Number 4, airplane. As soon as we see the word airplane, we get a little freaked out. Wind. Okay. Airplane is traveling due east. We got this. Yes? Due east. So if we wanted, we could just say cosine of what? 620 cosine of 0 degrees. Yes? Or we could just do, it's going 620. Oh, I sped that baby up. 620, 0? But if you wanted to do cosine of 0 degrees, sine of 0 degrees, that's what due east would be. Yes? It's pointing at 0. Okay. The wind blows at 60 miles an hour at an angle of 50 degrees with the horizontal. It doesn't say from, it says it's blowing it at an angle of 50 degrees. That's the happy kind. We're good with that because it just means it's doing this. Now, proportionally, that wind vector is a tenth as long as the other one, right? 60 and 620. So it's a short little vector. 60 at an angle of 50 degrees. So that one is 60 cosine of 50. What mode am I in again? Okay. Anybody add them already? Okay. Cosine? 38.6, 650, 8.6, like that? Okay. No? 60 cosine of 50 plus the plain old 620, 650, 8.6. That's what I got. This one is what? Okay, so roughly 46. Determine the velocity of the airplane. How do you find the velocity of the airplane after the wind has had an effect? Pythagorean theorem. That's it. Does it make sense? The plane was going 620, but the wind is pushing it, kind of, isn't it, here? So now 620 plus 60 would be 680. It's not pushing it straight behind it, right? But it's pushing it some. What's the best part of the whole question? It doesn't ask direction, right? The one on the quiz doesn't either. There is one that does ask direction. That's a bonus question. Can we do the direction real fast? What's inverse tangent of 46 divided by 658.6? Like 4.2 degrees. Anybody get that? 4.17 degrees? No? Did I type it right? I typed it wrong. Oh, I get 48. What is it? 3.99? Okay, so I'll go with 4 degrees. It's 4 degrees above, so you would say it's pushing it 4 degrees towards the north or north of east or whatever weird direction it was asking. All right. The rest of this, guys, is more recent stuff we've done. Not saying we shouldn't talk some more about some of these on Monday, though, okay? I will, listen, Monday I'm going to start arithmetic sequences, like when you add numbers, like 2, 4, 6, 8, 10. Those are arithmetic sequences, okay? But I will allot some time for questions. So if you want me to do some more on this review, because you went home, you tried it, you couldn't figure it out, or any of the rest of the book stuff, be ready. Quiz Tuesday. Have a great weekend. Yes.